All right, so welcome back, MIET 312 students. This is another lecture brought to you by Dr. Morgan Sears here at Bluefield State University. Today we're going to be talking about ARMPS Highwall Miner and how to use it. I'm going to show you some ideas for Highwall Miner layouts. We're talking about what some of the terminology means. We'll show you how to download, install, and get the software running and run through a little tutorial on it, okay? So with that, let's jump in. And today we're talking about highwall miner pillars, right? And there's two different kinds. We've got the web pillar and the barrier pillar. The web pillar is the smaller, the thinner pillar between two highwall miner holes. And then a barrier pillar is a larger pillar that's left between series of holes or panels of holes. In this case, you can see where they are mining out an area that's been auger mined in the past. So that does come up, as we mentioned before. But the problem is here on the right, the picture's kind of cut off, and you can't really see the size of the barrier. So here's a better example, of seeing how much larger that barrier is compared to the web pillars around it. And so the whole idea is that if you mine out a certain area, the larger the area is, the more likely you are to have a massive pillar collapse if your pillars are critically sized. And so if there's more deformation in here than what's expected, or the pillars start to fail, the concept of the barrier is that it stops the progression of that failure, limits it to a certain area, and protects the rest of the high wall, and of course the mine workers that are working there, right? So here's an example of a highwall miner layout. You can see, if I turn on my laser pointer here, highwall miner holes here in orange at the edge of the pit, right, at the high wall. You have multiple layouts here. You can see here there's relatively few holes per panel. A lot of them are 5, maybe 6 or so. There's also significantly sized barriers here, right? You can see in between the panels. When you get to the middle, much less barriers. I can't tell if these holes were shortened intentionally to provide more stability here in the back of the hole, but it doesn't look like it to me. It looks like they ran into something else in the process of mining. But here you really see no barriers at all, with the exception of a skipped hole here, it looks like. And then over here, once again, you pick up and see barriers again throughout the layout. So this is sort of standard. This is obviously a final map, right? Because the holes are not of uniform length. This is actually what was mined here at this site. This here is an example of, like a hilltop sort of topography where you have a coal reserve, and it shows that it's not big enough to deep mine, right? And so this would be an area where you would consider contour mining, maybe also utilizing a high wall miner or an auger system, something like this. So this is the sort of topography that's pretty typical of Central Appalachia. And so before we jump into how to use the program itself, I just wanted to leave you with this, and that is the consequences, if high wall failure are high. This is an example of a high wall failure. The high wall miner is completely destroyed. Fortunately, no lives were lost in this instance. But I had friends that worked at FOLA, right? This is where this was at, FOLA Coal Company in Clay County, West Virginia, just across the holler from where I first worked at. And yeah, I had friends that worked at this mine. This is, it's important to me. It's important to me personally, that we do the best that we can, in our jobs, and ensuring that these, high walls, are stable. So with that, let's get into, how to download and install the program and start running it. The first thing that you're going to do is go to minegroundcontrol.com. We've been here before, but this is the site that Dr. Zach Adjutanis of the University of Kentucky has for sourcing a lot of the ground control software tools that we use. This is the same place we got the BlastWind software. But here we're going to hover over ground control and then click on NIOSH tools. And this brings us to where you can download the NIOSH ground control toolbar. And it includes the following software: the ALPS program, analysis of longwall pillar stability, ARMPS, the analysis of retreat mine pillar stability, AMSS, the analysis of multiple seam stability, and of course, all of those have now been combined and upgraded with the ACPS software. But it also has a tool to help calculate the coal mine roof rating, the CMRR. ARMPS Highwall Miner, HWM, that's what we're going to be talking about today as it relates to surface mining and highwall mining. There's also the horizontal stress tool and ARBS, the original iteration of a tool for roof support design, roof bolt design. And that's now been taken over by the analysis of mine roof support, AMRS. Okay, so we'll only be using mostly one of these softwares, maybe two or three, not all of them, but download the whole toolbar just like that. Okay, so I got it back, reconnected to the internet and downloaded the software. So if we're going to go on from there, we'll click here at the downloads. We can click on that to start the installation process. We will click yes. And then it's the old looking Windows setup. Next. Agreeing to the terms is provided as is. Next. I just save in the default destination folder. If you're on a machine that doesn't allow you to save to the C drive, you may have to change that destination folder, but I'm just going to keep mine where it is. I like desktop shortcuts, so I'm going to put one there, and I guess the start menu too, even though that's not exactly a thing on Windows 11 anymore. So we're going to install. There it goes. There's everything. Next, we'll go ahead and click Run, and then Finish. And that brings up our toolbar, and it pops up right here on the right of my screen with all the programs that we had talked about. And if you click on ARMPS Highwall Miner, it will load the program and provide a disclaimer similar to the one you saw on BlastWind or ACPS or something like that. I'm going to go ahead and click OK. There is a reminder for updates, but there aren't any, so August 2013 is it. Okay. So this takes us to a screen that looks similar to what we looked at on BlastWind. Not identical, but so as the file, input, output, utilities, help, that sort of menu layout, right? The same kind of menu layout. In the file menu, you can obviously open or save, do all that stuff, print. In the input tab, you can input a project description just like you can in the other programs. You can choose your units. I typically use feet and pounds, but you can use metric if you'd like. And once you put something in there, typically maybe the mine name or what pit you're running, you can then go to project parameters. And here it allows you to input a certain number of parameters that you'll be using to calculate your pillar sizing. So in here, you can put an extraction height, such as 6 feet, and then a web pillar thickness of, let's say, 8 feet. Our depth of cover, relatively shallow, maybe 350. A barrier pillar width of, let's say it will be maybe 3 web thicknesses, maybe 24 feet. Let's try that. See what goes in there. And then the hole width will be the size of the miner head or the cutting head on the machine that you're using. In this case, I want to put in 11.5 feet. That could be typically a little bit conservative, maybe, depending on which machine you have. And let's just see what 10 holes does. You can go up to 20 per panel. There has been talks of updating this and maybe including a technique where you don't have to use barriers at all. I'm not sure exactly where that's going at the time, but for now, you do have to input a barrier, and your panel limitations are, like I said, up to 20 holes. And if we click results, that'll give us a quick answer of what we've got here. 1.8 overall. The webs are a 1.3. The barriers are 1.05. Okay, so the barrier is probably a little bit small, and the webs might be a touch big maybe. But let's go see what else is here. Next page, it tells you the size of the pillars themselves, their area, and the strength of those pillars, based on the Mark-Bianowski strength equation, which we will get into at some point. And so that's what we have here, the calculated results. Can also go to the defaults page here, which the in-situ cold strength of 900 psi. Once again, that's not a number that you would typically change. You would leave that the same for basically all cases, unless you knew very well a reason why it should be something else. The overburden unit weight, 162 pounds per cubic foot, and an abutment angle, which we will talk about that concept as well, 21 degrees, right? You can also go over to the sizing tab, where you can tell the program, what stability factor you want for your web pillars and what stability factor you want for your barriers, and then it will calculate it for you. So if we wanted a 2 for both, which is this sort of default value, our web pillars would have to be 12 feet wide and our barriers 36 feet. Typically, though, web pillars can have a significantly smaller stability factor, and if you have significant barrier sizes, then you can have something more like this, maybe a 1.3 and say a 2 there. So this barrier stays the same, but you might be able to get by with webs as thin as 8 feet. Okay. You can keep getting shorter and shorter and shorter, or narrower and narrower and narrower web pillars. But at some point, you do also want to consider that the thinner they are, the more likely you are to cross holes, in which case you would have to abandon that hole and move to the next. So keep that in mind, when you're sizing these things, and that maybe you want to have a little bit wider web, a little bit, narrower barrier, something like that. It just depends on how accurate, the machines that you have can mine. Okay, so we're going to go ahead and close out of that. I'm going to click on utilities to see you can do some things. Okay, you can output stability factors. Yes, we already looked at that. Let's go to the help file and see what's in here, and see if there's a there should be. Here we go. So some information on Highwall mining and how these plans are done. So there are ground control safety concerns associated with Highwall mining. So the NIOSH researchers with 40 Highwall ground control plans, the plans 80% came from Central Appalachia, so that's where we are. And most were between 2002 and 2004. So in these plans that were submitted, you had seam thicknesses ranging from 3 to 6 feet. Some have thicker seams, like 7 feet, and most of those are in the western U.S. Maximum depth of cover is less than 800 feet at most operations. Some of them may go up to 500 feet. Let's see. Seam thickness. Oh, uh, the seam thickness and the depth of cover being the main, inputs for the design of the web pillar. 15%, the ARMPS program was the analysis method. 25% used other forms such as the tributary area method for analysis. So even just about 20 years ago, we were using tributary area to do Highwall minor calculations. Yeah, width to height ratio is important. The more slender your pillar is, the more likely it is to fail. Width to height ratio above 1 is desirable, so that's try to keep so if you have a 6 foot, mining height, or you want to keep your pillars at least 6 feet wide. A little bit more than that might be better too. Stability factors, the ground control plans provided. In 45% of the cases, stability factor exceeds 1.6, and in 31%, it's between 1.3 and 1.6. So over 3/4 of the plans had stability factors above 1.3, right? Or even maybe even more than that. So that tends to give us like a sort of a bottom boundary of what one might be able to consider these stable. So that's a 1.3. Okay. Barriers were 10 to 25 feet. So that may or may not be good presently, but as of 2002 to 2004, these were working pretty well. 20 holes. Okay, yeah. 37% of the plans had no more than 20 holes. 44 specified 10 holes, and 15% requires just 5 holes between barriers. Okay, so they range from like 5 to 20, but probably most of the plans are in this 10 to probably 15 range. Okay, the reason for that is, so there are area sort of limits. So if you open up a large area of small pillars that are critically sized, you increase the chances of a massive pillar collapse. And by limiting the area, by strategically using barriers or the mining layout, you can then sort of use these, like I said, smaller, narrower pillars that have with the height ratios getting closer to 1. And still be stable overall because you have these barriers spaced closer together. So the area that you're creating these openings in does matter, and we'll talk about that in the future as well. Okay, and so remembering that we have web pillars that have these narrower, these width to height ratios of like 1 or the 1.25 range. Barriers, on the other hand, should be larger than that. Okay, we're talking like I said, up to maybe 25 feet, right? So in a thin seam or a thick seam, say 6 feet, we have a width to height ratio there of at least 4. Okay, so much higher than that 1 to 1.25 range. It appears to be based on these plans that a 3 or above for the barriers is a good idea, and has, like I said, has advantages. Okay, so with that, let's see what else we have over here. Stability factors. Yes, the sort of design guidelines. Okay, so overall 2.0, applicable to all conditions. Web pillars. So here's that area thing coming in. If the panel width, not including the barriers, excluding the barrier, exceeds 200 feet wide, then you need a 1.6. If it's less than that, you can get by with a 1.3. And then barrier pillar safety factors. If its width to height ratio is significant, more than 4, you can get by with a 1.5. And if it's less than a 4, you need a 2.0 to ensure that it's stable. Okay, so these are the criteria for the design criteria using this program. That is, once again, this is an empirical model. Okay, so A tremendous number of case studies were taken and included, in this sort of statistical database, right? So the design criteria for this is based on the statistical analysis of those successful and failure cases, right? So, once again, this gets you into a range that's close to, like, basically 90%. I don't want to say it's not accuracy, but correct classification, right? So you basically have a roughly a 90% chance of success when you meet these criteria. All right, so let's go back and do an example using these criteria here. No, we have to exit out of here. We're back. Okay, input, project parameters, sizing. So we want a barrier pillar that's, wait a minute, we need to add in the our information here. Our seam's going to be thinner this time. We're only going to be 4 feet, and let's reduce that cover back down to about 300 feet. See where that's at. Hole width 11.5 feet, and then so if we go 10 feet, let's see, we'll go to sizing now. We're going to try 1.3 for our webs, and a stability factor on the barrier of 1.5. Let's see if we can see what that does here. So to get a 1.5 on the barrier, we need web thickness is 21 feet. That's a with the height ratio of over 5, right? So we're good there. 1.3 on the webs gives us a web thickness of 5.6 feet, and so, or 5.9 feet, sorry, so almost 6 feet. We would probably just say it's 6. And that is what, a width to height ratio of 1.5. So that's maybe even, pretty good there. So let's see, by doing some math here, if we know that our web pillar thickness is 6 feet and our hole thickness or width is 11.5, that's 17.5 total. And so if we did 10 holes, that gets us to 175, 11. I think we could do 12 because that gets us to 210. But there's a barrier there next and not a web pillar, so we would have to subtract 6 feet from that. So you could get really close to pulling 12 holes here per barrier in this scenario. But let's say we want to do something more like 20 holes. We want to do as many holes as we can. And we'll go back to sizing. Our stability factor for our web pillars is probably going to have to be, we might be able to get by with 1.3 again. We will try. And let's just see. Let's size our pillars here. So the barrier can still be a 1.5 in this case because it's, more than 5 times the width height ratio is more than 4, right? Or even 3, they said would be maybe be suitable. So we're in a 5 range. 1.5 is good. Suggested web thickness is still these 6 feet, right? But we've exceeded that the area that's allowed for a stability factor of 1.3, and so we're going to bump that up to a 1.5. Okay, resize the pillars, and we get a 6.64. So if we have this layout, we have 1.5 stability factors for both the webs, and the barriers. You could get up to as many as 20 holes prior to leaving a barrier. So a lot of times it just depends on what your end goal is. It also depends on mining conditions, the highwall conditions, right? If you have some sort of slip or mud seam in the highwall, it may be a good idea to just skip that hole or even leave a barrier there in its place, right? And then mine more on the sides. So make up for it, but leave the support where it needs to be. And that's easier said than done. Um, to get better at this, I think we're going to need to get into more scanning, of high walls and that sort of thing. Which I'm hoping that'll be facilitated, with the use of drones and or even for large pits, maybe even stationary scanners would be good. But so that sort of concludes, how to use the ARMPS Highwall Miner program. We'll go into a lot more detail later, particularly once we get into the rock mechanics class, about how the background of how all this works, how the stresses are calculated and all that sort of thing. But with that, this is what you need to design high wall miner holes for your basic layout. Okay, this does not include the impacts of multiple seam mining, which is more common now than ever. It's historically you've had high wall miner holes over top of one another, and stacking those has resulted in reasonable stability. But we're talking about maybe high wall mining over old deep mines, right? That have had full extraction take place, and their stress distributions are a lot different than they were, and you have these interactions, and so that's not taken into account here. That needs to be addressed either through numerical modeling or something else to get to that point. It also doesn't address if you're going to say high wall miner reserve that already has auger holes in it. There are techniques out there for that. I'll see what I have on that, and we'll talk about it. But it's you have to basically consider that part of it's already gone. How much more can you take and it still be stable as a whole, right? Because the main takeaway from pillar design as it is that the pillars don't really respond kind of individually. The system works as a whole. So that's kind of the take home from that. But with that, I'm going to conclude this presentation on using the ARMPS Highwall Miner program. Feel free to reach out if you have any questions or would like to go over any scenarios. And yeah, we'll see you next time.